This is second lecture of rank of matrix, chapter number 1, algebra, BSc first year, first sem. In this chapter, we will discuss about second method to find rank of a matrix, which is known as elementary transformations or elementary operation. Why this method comes out? Because when we talk about higher order minors, means we have to solve mode of higher order, that is 4 order 4. I don't know how to solve it. In previous question of minor method, if you do not watch this video, then go back and watch this video. In previous question, where we have a 4 order 4, I mean to say this question, here we had a 4 order 4, but we solve it. How we solve it? We are solving it by multiplication and we get 0 rows. That's why we solve 4 order 4. But in case our rows are not 0, how we solve a 4 order 5 order 5, 6 order 6, or maybe 4 order 5, means 4 rows 5 columns? How we can solve? We know that minor method is only capable for square matrix. So what we do? So that's why elementary operation comes. It helps us to, so therefore we find some method of alternating a matrix such that ranks remain array. This is a matrix which is 3 order 3. After applying some operation, it remains still 3 order 3, but changes that elements changes. If here is 1, here is 2. Something happens here by elementary transformation. That is called elementary transformation. Okay, so it's make alternate matrix which is of same rank, okay, but simple to find rank. These methods are based on operations called elementary operation or transformation. Let's talk about types of operation. The interchange of two parallel lines. What parallel lines? Like this. This is your row and row. इसकी जगह पर ये वाली row का we can place this elements at here, we can place this elements at here, okay, or also in column wise. Okay, we place this column elements here, we place this column elements here. Interchange is possible. The multiplication of all elements, like when we make equation 2x minus 3y is equals to 0, we multiply the equation with 2 as it is. We can multiply a row or a column with any real number, or also the addition of element, like this is your row 1, this is your row 1, this is your row 1. I'm adding row 1, yeah, say subtracting, okay, by multiplying 2r2, मतलब सेकेंड रो को पहले मैंने मल्टीप्लाई किया 2 से, फिर मैं प्लस माइनस कर रहा हूँ से रो 1 से, उसे कहते हैं एलिमेंट्री ट्रांसफॉर्मेशन. इस 3 तरह के एलिमेंट्री ट्रांसफॉर्मेशन पॉसिबल है, प्लस माइनस वाला, या किसी नंबर के साथ मल्टीप्लाई वाला, या फिर इंटरचेंज वाला. ओके, दैट्स व्हाट रिटन हियर. नेक्स्ट, देयर आर 2 टाइप्स ऑफ what transformation. First is row transformation, second is column transformation. Row transformation, why we have to know that what is row and what is column? You know the row is in matrix, these are your rows, you know it already, and columns are this, you know it, maybe you know it, column, row. Okay, let's start. So row transformation means row interchange. This is symbolic representation. If we have to write interchange, we use this sign, or we can write R12. That means you are changing 2 at the place of 1 and 1 at the place of 2. Say as it is, column 1 at the place of 2, column 2 at the place of 1, or column 1, column 2 interchange. Okay, this is what this means. Row 1 multiply हो रहा है E के साथ, or maybe it is written as row 1 किसमें चेंज हो रही है? E के साथ मल्टीप्लाई होकर R1 में. E is not equal to 0. We have to multiply with the non-zero number, not a zero number. Okay, not 0. 0 के साथ आप मल्टीप्लाई नहीं कर सकते. सेम इन कॉलम केस, कॉलम 1 मल्टीप्लाई हो रहा है E के साथ, जो कि एक नॉन जीरो नंबर है. मल्टीप्लिकेशन ऑफ R1 बाय E नॉट इक्वल टू 0. और R12, व्हाट दैट मीन्स? 12 means interchange? No, here 12 means 1 as it is, 2 is multiplying with k, 2 is multiplying with k, and there is some case plus or minus. Okay, that's it. Is that clear to you? This is all about elementary transformation. we have to discuss method, but before discussing method, let us know some things like what is equivalent matrix. In minor method, we write this sign. This sign means, this sign shows equivalent matrix. Equivalent matrix means कि a matrix which has the same order. Same order means 3 order 3, and what the rank is coming out, it always rank comes to R. For any matrix ka rank is always R. What we alternate the matrix. This is the method how to solve it. So let me explain this method which is written here. This is simply written, but we have to explain it. So let's get started. You already know that, na? This is A11, this is A12, this is A1, A33, A21, A22, and this is A33. You know that. Okay. We can approach this matrix to the infinity. Okay, we do that. This is about n1, this is n2, this is n3, this is n4, this is a1m, this is a2m, this is a3m, this is amn. I can approach it, but the case is that this is our your diagonal elements. You know that these are your main diagonal elements which are at diagonal. Matrix of any order like 4 order 4, 5 order 5, 4 order 5 means matrix of 4 cross 5, 5 cross 5, 6 cross 6, 3 cross 3, 3 cross 2, 4 cross 2, 4 cross 5. Any matrix of any order, any number of rows and columns. How much row number column does not matter. We can apply elementary operation by this method. What is the method? That at diagonal elements, this means this A11, A22, A33, A44. At diagonal elements we have to make 0. How we can make that we will discuss. And at elsewhere we have to make what? We have to make zeros. What this shows? This shows an identity matrix. We have to make a identity matrix. What is the definition of identity matrix? Identity matrix means at the main diagonal there all elements are 1 and elsewhere is 0. That means identity matrix. So is that clear to you? We have to make 1 at the diagonal elements and elsewhere 0. How we can make it? I have an example of 3 order 3. We can solve any example by this method. If it is 4 order 4, 5 order 5, 6 order 6, we can solve it. Why I choose this example? Because it is easier to digest this example. 1 2 3 1 3 0 0 1 2. First I ask you to this is 2, sorry, this is 2, this is 2. Okay, so now what I have to do, make here 1. This is your first step. Okay, this is your first step. Make here 1. This is your first step. How you can make here 1? You know there are 2 types of operations, row and column operation. What operation I use here to make here 1 in this matrix? I do this. Why I write this sign? Equivalent matrix means same rank or same. What operation I am using here? What operation I am using here? Anyone tell me? Yes, this is your R2, this is your R1. Very good. I can interchange R1 with R2 with interchange sign. So 1 3 0 2 2 3. Very good. 0 1 2. It remains as it is. Only 2 rows are changed. Now this is your first step. Now with this step you can do 4, not 4. You can do 1 2 3 4 5 6 infinity sub steps. Means with this first step you can do this 0, this 0, this 0. With this, only this step you can make this 0. How you can make this 0? Let me show you. These are the sub steps, approaches to infinity. How you can do that? Like here you make 1. Here you make 1. What that means? What that means, you by any operation you did it, you here make 1. So by this one, this first step, you can 0 any full row 4 column. Why only this one? Why only this one? Why only this one? Because this is a 1 1 element, means first row and first column can be 0 by this. So I am going to 0 this by only this, How I can do this? You know the order, you know how to write order, row into column. I did this, I did make here one. So first of all, I am this A1 element place, at A1 element place, I am going to 0 this row. I am going to 0 this row. Here I write 6. Here I am writing 6 to make it more difficult. Here I am writing 6 at the place of 0. Okay. Now what I am doing here, I am making here 0 with this step, full row 0. How I can make? If I row 2, this is your row 2 na? Row 2 minus 2R1. 2 के साथ 1 का मल्टीप्लाई तो क्या हो जाएगा? -2 और ये क्या है? +2. -2 +2 कैंसिल हो जाएंगे. सो आई कैन मेक हियर 1 3 0 0. Here I make 0 with this, with only this. Now here one more operation I can apply. R3 minus 6R1. 1 है ना, 1 के साथ 6 की multiplication gives you -6. This is +6, -6 + 6 cancel out. This is 0. Now whole work, not only on this, also on this it works. How it works? Like here is R2, right here R2 element -2 into R1 element at second place is this. That is 2 minus 2 3 the 6. That is -4. It comes out to be -4 here. It comes out to be -4 here. Now what I am doing here? I am writing here at the place of 0 to complicate sum. I am writing here 8 to complicate sum. Okay. So here R2 at the place of R2 I am writing 3. Here 2 into R1 third element is 8. That is 3 minus 8 to the 16. And this is what? 16, 15, 14. That is -13. -13. Okay. So here I write -13. I am doing the sum more difficultly. Now what I am doing here? I did it 0. I do all about this operation completed. This operation completed. Now I have to complete this operation. I make here 0 already. So R3 contains 1. So here 1 minus 6 R1 contains 3. 1 minus 6 3 18. That is very good. 17. That is 17 with a negative sign. See the sign. Okay, clearly. Okay, now here is 2 minus what here it is? What is here it is? 2 minus here is 2 and here is 8. 6 into 8. 48. 2 minus 48. 48, 47, 46 minus 46. That's what I get here. Now this step has been completed. I tell you that this whole row can be 0 and this whole column also can be 0 by only my first step, which is my main step. Then all are my sub steps in A11 element, okay, which are in A11 row and column. So now how to make this 0? Anyone knows? Yes, you know that. How? This is your column. This is your column 2 na? Column 2 minus multiply by 3 column 1 or column 3 minus 8 column 1. Okay. Now what happened here? 1 0 0 0 0 or 0 minus, here you write, here see clearly. Okay, column 2, this is your column 2, that is -4. It is your -4. Column 2 contains -4 -3. Column 2 -3 column 1. Anything changes? Oh sorry, I am going towards 2. This is your column. So 1, you get 1 this is -3. It cut out -8 -0. Not means anything. Here I write column 2 contains -4. Here 3 into 0 in column 1 second element is 0. So -3 into 0, that is 0, -4 as it is. So it never changes. Here nothing is changed. That's why we do this operation first. That's why we do row operation first, or also A11 we talk about row first because we write order like row into column. So is that clear to you? Now what I have to do, this first step and their sub steps are completed. Are they completed? Yes, they are completed. Now what I have to do, I have to make next diagonal element 1. Means I have to make -4 is equals to 1. This is my second step. This is my second step. This is my second step, and they are its sub steps. They are its sub step. They are sub steps of this. Means row 0, column 0. Now let me make here 1. How I can make here 1? Anyone tell me? Anyone? No one? Anything by row or column operation. So which row or column operation I can use? I don't know. Here 17 minus 4 nothing, 40 minus 13, so I can't do anything. I know 3 types of operation, that multiply by any number, subtract or minus by any row or column, that I know, but here nothing works. So what I do hit and trial method. R2, this is your R2, this is row 2 divided by row 2 divided by row 2 minus 1 by 4 row 2. Okay, minus 1 by 4 row 2 means row 2 multiply होगा minus 1 by 4 row 2 के साथ. तो that is this element. 0 होगा तो कुछ नहीं आएगा, वो तो 0 रहेगा. This element means this element is going to be start. Now I am writing -4 upon 1 upon, here -4 multiply with -1 upon 4. So minus cancel out, 4 cancel out, that gives you 1. Here 1 comes. Here it's clearly seen na? Yes, it's seen. 1 0 0 0 0. What comes? 0. Here also changes. -13 into -1 by 4. Minus cancel out each other. That gives you 13 by 4. It gives out 13 by 4. Now -17 -40 as it is. What I have to do? Let me tell me that what I have to do. What I have to do? This one helps me. This one helps me to make this 0 and this 0. What I have to do first? I have to do this 0 first. First row. Why row? Because I tell you it. Because I tell you this is a 2 element. So firstly we go towards row. As we know, row into column is your order. So I am making it 0. How can I can make it 0? This is your what? This is your row 2. But I write here row 3. Why? Okay, row 3 plus 17 into R1. Here 17. Here I write 1. 1 into 17. What it makes you? 1 into 17 makes you plus 17. Or here is minus 17. That is 0. So here the operation is working. So here is 1 0 0 0 0 1. Here also 0 comes. Here minus 13 by 4. Also here some changes occur. How occur? Here minus 13 by 4. Here I write minus 40. Okay. Minus 40 plus 17 into 13 by 4. Now what I have to do? I have to multiply them. Let's continue what we are doing. We are doing this minus 40 plus 17, 13 by 4. We can't cut here. No cutting here because it's odd. It's also odd. So we multiply this. This is 221. Then this, because here is plus not multiply sign, so we can't cut here. 4 into 10 40. Don't do this mistake. It's in plus not in multiply, so don't do cutting here. So it's minus 160 plus 221. This is plus minus, that gives you 71 by 4. So here in the matrix I can write 1 where I am writing matrix 1 0 0 0 1 minus 13 by 4. Or here comes, here what comes? Here comes 0. Here 0 comes out. Here also 0 comes out. Here has come out 71 by 4. Now what I have to do? I have to remove this number. I have to remove minus 13 by 4 by this second step, which is my main step. These are my sub steps. Now do this. How I can do this? This is your column. This is your column 3. Column 3 minus plus 13 by 4 column 1. 13 by 4 say multiply. Then this will gives you 1 0 0 0 1 minus 13 by 4. Minus 13 by 4. Here I write minus 13 by 4. Here I write plus 13 by 4 into what's the column 1 element? This is 1 here. second element is this. So minus 13 by 4 plus 13 by 4, they are cancel out each other. So it is also 0, 0, 0. Still one thing left, 71 by 4. Why it not changes? Because here is 0. Here is 0. That's why it's not changed. Here, if we write it, if we write here, this is your column 3 element. What is this? 71 by 4. Okay? Plus 13 by 4 into third element is 0. That is plus 0, 71 by 4. 71 by 4 still left. Now what I have to do? I have to make here 1. How I can make here 1? If how write in this form, we forget something. We have to write here equivalent sign. Write here equivalent sign. This is your equivalent sign which you have to write at everywhere when you applying elementary operation. Now I have to make here 1. This is your third step. If this is your third step, if I will tell you, if there is also some numbers here, then first of all you make row 0, then column 0. Okay, remember this method, row into column. First you have to make row 0 and column with this method. Okay, where it is? Here it is. Oh. Now let me do this. How I can do this? Tell me anything. How I can do this? If this is what? This is row 3 or column? Any operation, apply any operation. If we apply row 3 multiply by minus 71 by 4, row 3 4 by 71 into क्या R3. Okay, so here I am writing 4 by 71 into 71 by 4. They cancel out each other. Minus 4 by 71. Okay, so here 1 comes. This is hit and trial method. This is hit and trial method to solve this matrix. Okay. Nothing is impossible. You have to do practice. Here 1 comes out. Here 1 comes out. So how this matrix is solved? This is an identity matrix where diagonal elements are 1. This is an identity matrix where diagonal elements are 1. So this is the method how elementary operation works. Let me show you how I write here. How here star means row operation and this sign means hash means column operation. So you have 1. To make here 1, I write both signs. Why I write both signs? Because there are both signs are valid. We can use row and column operation, anything. Here this is your first step, then this is your subset, second, third, fourth, where you can only use row operation. As here we use only row operation to do this 0. So here you can only use row operation. Here you can column operation. So here is hash. When I make it 0, I use column operation. Then here is 1. Anything row and column operation. This is your third, fourth, fifth, sixth, seventh. जितनी भी long हो आप ऐसे कर सकते हो. ठीक है. 8th. This is your 8th. There is hash and star both because here we have to make 1. Here next step is 9 and 10. This one because here is star because we have to use row operation. Here then column. Here 1 star. दोनों operations. Both operations can be used. Here 1 operation which is row. Here column operation. Here then we have to make what? 1. So we use column and row operation both. Okay, is that clear to you how this works? Okay, how it works? This is how it works. This is given matrix. What I do, it transfer here. Okay, then make it 0. I use row operation. How I do? 2r1 or minus r1, and this is 0 and this is also 0. Now 1 3 minus 2 0 minus 7 8, it comes out. Okay, after this also r2 minus 2 r1, this comes. Now I have to make this 0. How I make? By column operation. How column operation? Column 2 minus 3 column 1, column 2 plus 2 column 1, it cut out. 0 0 comes. Here I have to make minus 0. How I can make? Here I have to make 1, but I can't make because I see here 7 to 14, 8 to 16. So I just do what? This simple operation r3 minus 2r2. Okay, so you have to see the matrix carefully. Sometimes it's easily solved. R3 minus 2r2, then it will gives you 0 0. If it is 0, number of non-zero rows are this. These are the number of non-zero rows. So row A is equals to 2. It comes out to be 2, not 3, because 0 0 vanish. Or if you make a 1, then 7 into 0 0 0 into 8. If you make minor of 3 order, it also vanish. Only 2 order does not vanish. I am writing here 2 order 0 minus 7 1 into minus 7, that is minus 7 into minus 0, that is minus 7, which is not equals to 0, non-singular matrix. Here it comes out. Okay, that's how it is solved. Now some important points, and then we finish this lecture and talk about examples in next lecture, in next part of this video. Number of non-zero rows after applying sufficient operations, number of non-zero rows is equal to the rank of that matrix. रैंक क्या होगा, जितने आपने ऑपरेशन अप्लाई कर दिए बस हो गए और नहीं कर सकते, तब आपका वो रैंक ऑफ मैट्रिक्स होगा. अब ये जो मैट्रिक्स हमने निकाली, इसका रैंक क्या है, नंबर ऑफ नॉन जीरो रोज आर 3, तो इसका रैंक है 3, और ऊपर से ये 3 ऑर्डर 3 की मैट्रिक्स भी है, ये I3 मैट्रिक्स भी है, मतलब आइडेंटिटी मैट्रिक्स जिसका 3 ऑर्डर है और 3 ही रैंक है. नंबर ऑफ इज 3. क्या हम और ऑपरेशन यहाँ पर लगा सकते हैं, तो नहीं. अगर मैं यहाँ कॉल ऑपरेशन लगाऊँ तो नथिंग वर्क्स. अगर इफ आई अप्लाई, यहाँ मैं 0 बना सकता हूँ, नहीं बना सकता, कोई भी कोशिश कर लूँ. 1 डिवाइडेड बाई 1 दैट गिव्स यू 1. ओके, not use 0, we have to use only non-zero numbers. By applying non-zero numbers I make this all 0. If you use here column 2 divided by 0, then it all zeros, this is also 0. We have not to do this because it is given that we can't use non-zero numbers. Okay, elementary operation are also applied on which is not a square matrix, square type matrix, क्योंकि as we know we can make this step as far as we can, so anything. Elementary operation, number of column after applying sufficient elementary operation, number of columns जितने भी बचे होंगे, same case for row और same case of column, जितने भी columns बचे होंगे elementary operation लगाने के बाद वही उसका रैंक होगा. Number of columns which is not 0. The value of rank of matrix is always, rank of matrix जो है वो हमेशा less होगा than the order of matrix. Why? As we know, if it is a 3 order 3 matrix, then this vanish means this row and this row is not here, is it 0 0 0, then the rank is 2, so it is always less, rank is always less than the order or equal to the order, not more than that. Rank can't be more than order. That is wrong. If it comes for your question, then you are wrong, you are doing wrong your question. That's it for today's video.